Hey, so I cut the video there, but anyhow, so this one was a rhombus. Now, why? Well, it's not a rectangle because these diagonals are not equal. They are bisecting each other, but that doesn't make them equal. Um, you know that here, okay, since the parallelogram, angle U and W are congruent, and half of W is equal to half of U. That means the other half of W must equal the other half of U. Okay, and so you have this by theorem 620. If a diagonal is bisecting the angles, it's a rhombus. All right. Another way you could prove that this angle here that wasn't marked, okay, it wasn't marked originally, is the same, is by alternate interior angles. Because it's a parallelogram, you have parallel sides and alternate interior angles are congruent. All right. In the next example, you're using that same idea here. Diagonals are bisecting the angles. TV is bisecting the two angles. And you're just asked to figure out what x and y are. So just set the two equal angles together. Okay, you can see them, both sets of them down here. And you can solve for the appropriate variables. Okay, so just remember you're undoing the equation. And so you could actually subtract 5x first or subtract 4x first. The book always gets the variable on the left side, so that's why they went negative here and also on the other part. All right. Okay, here's a different question. We have a parallelogram ABCD. We don't have a picture, so we got to draw it. Da 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 da. Here's the picture. Okay, I already drew it for you. So what we need to figure out is, well, what AC is. Oh, AC is a diagonal. BD is another diagonal. Okay, for this to be a rectangle, what must be true? Well, the diagonals must be equal. So, da 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 da, we set the diagonals equal to each other. Distribute here to get 2w plus 12. If you solve the equation, you'll get w equals 13. So w must be 13 for this to be a rectangle. Okay. All right, here it's a softball, kickball field. Okay, 60 feet apart on the bases. Can we verify it's a square? Well, it's a square if it is both a rhombus and a rectangle. All right. Well, since opposite sides are congruent, we know it's a parallelogram. We also know it's a rhombus because all the sides are the same. Now, do we know enough to prove that it's a square? Well, to verify that's a square, and you can't unless you get a tape measure, you would have to find the distance from second base to home plate and from first to third. If these are the same, we know it's a square. Because remember, by theorem 621, which is the one I didn't actually have on the paper there, to be a square, okay, it has to be both a rectangle and a rhombus. And what theorem 621 says, in a rectangle, the diagonals are congruent. All right. Okay. Last problem here. Is this a rhombus? Okay, don't read it here. But it is a rhombus. Why? Well, first, you need to know it's a parallelogram. The reason why it's a parallelogram is simply because the diagonals are bisecting each other. And there's a theorem back in lesson 6.4 about what proves it's a parallelogram. The other thing that makes it a rhombus is the fact that you don't know anything about the diagonals bisecting the angles, except for it's bisecting this one angle here, okay? But it has to bisect two angles, one diagonal, so you can't use that theorem. However, you know measure of angle MRQ. The measure of MRQ is equal to 90 degrees, and you get that because you have a triangle here from M, R, and Q. You know two angles, so just subtract from 180, and you get 90 degrees. And by theorem 619, it's a rhombus, okay? Because diagonals are bisected not bisected. Diagonals form perpendiculars in a rhombus. So I hope that makes sense to you guys. And that's about it. Hope you guys have a good day.